In this video, we're going to continue on the notes that you started. It was called absolute value solving. We're going to continue on those notes. Today, we're going to look at solving absolute value inequalities. So if you could just add what we're doing here today, just below the notes that we started last week. So to solve an absolute value inequality, so if we're given this one, let's say, we have absolute value of x divided by 2 minus 5 is less than 15. Notice there's nothing with the absolute value, so we're okay just to go ahead and make our two inequalities to solve. The first inequality, we're just going to remove the absolute value bars. So it's going to say x divided by 2 minus 5 is less than 15. The second one, there's two changes that are going to make. So this is where it becomes a little bit different from when we solve absolute value equations. So this time, when we make our second inequality, x divided by 2 minus 5, we're going to flip the inequality sign. So notice this says less than. So I'm going to flip it so that it says greater than. And then we're also going to change the sign of the number. This is the same as what we did when we solved absolute value equations. We changed the sign of that number. So there's one new piece that we have to remember when we solve an absolute value inequality, and that's to change the sign of the inequality. Other than that, it's pretty similar to solving the absolute value equations. So you're going to draw, So you're going to draw your lines down the absolute value signs, and we're just going to solve each of these. So these are should be pretty familiar for you to solve. So I'm going to kind of run through these pretty quick. So we're going to add 5 and add 5. So those 5s cancel. So I get x divided by 2 is less than 20. And then I'll multiply both sides by 2 to get rid of the 2. So this gets me x is less than 40. So this is one solution. For the other solution, it's going to be the same problem. Now I just have negative 15 on the other side. So plus 5, plus 5. So those 5s cancel. I get x divided by 2 is greater than negative 10. Multiply both sides by 2 so that those 2's cancel. And I get x is greater than negative 20. So the solutions to this inequality have to satisfy either x is less than 40 or x is greater than negative 20. So it has to satisfy either of those to be a solution. I'm going to graph the solutions to this one on a number line since it's an inequality. So here's my number line. I'm going to call this 0, 20, and 40. And I'll call this over here negative 20. So I'm going to plot each of these on the number line. I'll plot the first one, x is less than 40. I'll plot that in green. So x is less than 40. So open circle at 40, shade to the left. For the next one, I'll do it in red. X is bigger than negative 20. So bigger than negative 20. So open circle, shade to the right. So your solution region is going to be where these two lines overlap. So if you did this on a paper, you won't be able to pick one line up and put it on top of the other, but I can. So your solutions region is everything in between here and here. So if you want to draw it on your paper, draw it like this. So this is your solution region. So any of these values in this region here make the inequality true. So these would be your solutions. So those are your solutions. For this next example, I have absolute value of negative 3x minus 1, all divided by 2 is less than or equal to 3. So what we're going to start off here is notice there's division by 2 on the outside. So you're going to draw the line and multiply everything by 2. So these 2's cancel. I get absolute value of negative 3x minus 1 is less than or equal to 6. So now you can create your two inequalities. So the first one is going to be negative 3x minus 1 is less than or equal to 6. And the second one is negative 3x minus 1. Remember, flip the sign because we're changing the 6 to a negative, so we have to flip the sign. So we're going to flip the sign and make the 6 negative because it's like we're multiplying by a negative. So we flip the inequality sign. So these are just two linear inequalities, which you should know how to solve each of these. So you'll solve this one, and then you'll solve that one. I'll go over, so if you want to pause the video and try it, and then I'll just briefly go over it after you unpause the video. So hopefully you paused the video and gave this one a try. So I made it so you could see the solution steps here. So the first thing you want to do is add 1 to both sides for both inequalities so that those ones cancel. So in the first one, you get negative 3x is less than or equal to negative 7, and then divide both sides by negative 3. So remember, when we divide both sides by negative, when we have an inequality, you need to flip the inequality sign. So this becomes x is greater than or equal to negative 2.3. So I use the decimal here because I know I'm going to need to plot this on a number line. The second one is solved in a very similar way. You add 1 to both sides. So you get negative 3x is greater than or equal to negative 5. And then you're dividing both sides by negative 3 because negative 3 is in front of the x. So when you do that, you get x is less than or equal to 1.7. So these are your two solutions. X is greater than or equal to negative 2.3. X is less than or equal to 1.7. So I'm going to graph those on the number line. This is the one part I want to do with you just so you can see it. So here's 0, here's 1, here's 2, negative 1, negative 2, and negative 3. So I'm going to plot both of these on the number line. So I'm going to plot x is less than or equal to negative 2.3. So here's negative 2.3, maybe somewhere around here. Move this down. So maybe about here. So this is negative 2.3. I'm going to have a closed circle at negative 2.3. And it says greater than, so I'm going to shade to the right. Then I'm going to plot x is less than or equal to 1.7. So I'm going to do that one in blue. So 1.7 is pretty close to 2, so maybe here. So 1.7. Again, this is a closed circle, and this time it's x is less than or equal to that. So I'm going to shade to the left. Notice those, if I was to take the blue line and put it on top of the red line, they overlap. So their overlap is the solution region. So their overlap is in between negative 2.3 and 1.7. This is your solution region, what I'm highlighting in purple. So your solution region is this. So here's another example. 4 times the absolute value of x plus 2 is greater than 12. So notice I have multiplication by 4 out front of the absolute value. So I'm going to start off, draw the line, divide everything by 4, because that undoes the multiplication. So now I have absolute value of x plus 2 is bigger than 3. Now I'm going to create my two problems. So I'm going to say x plus 2 is bigger than 3. And then the other one is going to be x plus 2 is less than negative 3. Remember, since I'm changing the sign of the number to negative, I need to flip the inequality sign. And then you're going to solve each of those. So draw your line and then solve. So I'll let you pause the video and solve those two. When you unpause the video, I'll have the solution there for you. So here, the inequalities are pretty easy to solve. All you had to do is subtract 2 from both sides for both of the inequalities. So you get x is greater than 1 or x is less than negative 5. X is greater than 1, I shaded that in green. So open circle at 1, at positive 1, shade to the right. Open, and then open circle at negative 5, because x is less than negative 5, and shade to the left. Notice these two inequalities don't overlap. That's fine. Your solution region is just going to be the green line and the blue line. So this is your solution region. So nothing in between those two satisfies this. So there's two special cases that we get when we work with absolute values inequalities. So the first special case is absolute value of x minus 2 is greater than or equal to negative 5. So when you think about this for a minute, we said previously that absolute value is always positive. In other words, I would like you to write this fact below these two special cases. So here's a fact. Since absolute value is always positive, that means absolute value of x is greater than or equal to 0. It's always got to be positive, right? So in special case number 1, I have absolute value of x minus 2 greater than or equal to -5. Well, think about this for fact number 1. I have absolute value of x minus 2. Remember, on the left side here, this is always positive because this is just an absolute value. It's always greater than or equal to 0. So on the left side, I have a positive number, and then my sign says greater than or equal to -5. Well, this is a negative number. Well, this is always going to be true. No matter what number is inside my absolute value, whenever I take the absolute value, remember, I'm going to get a positive number. So a positive is always greater than a negative. This is always true. So I'm going to say that there are many solutions. Or you could say all real numbers. You could say all real numbers. So there's infinitely many solutions to that first one. So for the second case, the one that you see on your screen right now, it says absolute value of 3x plus 11 is less than or equal to -2. So the absolute value of 3x plus 11. So remember the fact that we wrote down earlier. The fact is that absolute value of x is always greater than or equal to 0. So remember, absolute value is always positive. So no matter what, when I take the absolute value here, I'm going to get a positive answer. So this is going to give me positive. And then the rest of that statement said absolute value of 3x plus 11 is less than or equal to -2. So less than or equal to -2. Well, -2 is a negative number. So is this statement true? Is a positive number, no matter what it is, less than or equal to a negative number? And the answer there is no. This is always a false statement because positive numbers are always bigger than negative numbers. So this is a false statement, so there are no solutions. So write no solutions for that one. Because this is going to give you a positive, this is less than or equal to a negative, and that's just never true. Positives are always greater than negatives. After watching this video, you should be able to complete the Google form that's in Google Classroom.